so far in your math career, you've dealt with exponents of 1. That's our linear. You just get everything on one side, keep your x on the other side. You've dealt with your quadratics with your x squared. You factor. We have all our different ways of factoring. Even, if you have an exponent of 3, most of the times you're going to factor. So this is just another way for us to solve other equations that you haven't gotten to yet. So first thing we need to do, and it's a key step, is you need to isolate the expression containing the exponent. So it's always going to be a variable that has your exponent that's either a fraction or negative. You want to get that on its own. So you add, subtract, multiply, divide, whatever you need to do to get everything else away. And then you're going to raise both sides of the equation to the reciprocal power. So what that means is, let's say, for example, we have x to the 2/3. What we do is we raise it to the reciprocal power, meaning you want to flip the exponent. So you raise it to the 3/2 power. You just flip that fraction. Because what ultimately ends up happening is if I take my 2/3 and I multiply it times my 3/2, which that now tells us to do because we have a power to a power, multiply across your tops, we'd get a 6. Multiply across your bottoms, we get a 6, which would reduce to 1. So what it does is it gives us the exponent of 1, which is what we want to have. So we want to eliminate the exponent to leave us with a 1. That's why we do the reciprocal. And then you solve the remaining equation, and you check the solution in the original equation. So let's take a look at our examples. Example 1, x to the 1/2 equals 9. So we already have x by itself. We don't have to do anything else there. So I'm going to raise both sides of my equal sign to the reciprocal power, which would be 2 over 1, but I don't have to write the over 1, so I'm just going to write it as a 2. So then the 1/2 and the 2, they cancel each other out, giving me x to the first. I'm going to have x equals. And then what is 9 squared? 81. Then we should just do a check over here. Plug in 81 for x, so 81 to the 1/2. We're going to see if that equals 9. And we're going to do a little review of day 1, since that's going to be on your quiz next class. 1/2, how do I change this? I get a radical in there, but what kind of radical? What root is it? So it's the square root of 81 to that first power. Which, what is the square root of 81? 9. And then to the first power, it's still 9. So yes, that checks out. Of the fractional exponent, the bottom number is your root, yes. All right, so number 2, x is not on its own, so I got to first do what? Subtract the 1. So x to the 2/3 equals a 4. Now the x is isolated, so I'm going to raise both sides to the reciprocal power, which would be 3/2. You just flip it. So those cancel. I'm left with x on the left side. On the right side, again, let's practice this. This means I have the square root of 4 to the 3rd power. Not if it specifically tells you to show radical form, which is why I'm going to keep reviewing it this way. I know you could just type in 4 to the 3/2 in your calculator, but I'm specifically practicing that skill with you. So what is the square root of 4? 2, and then 2 cubed? 8. We get x equals 8. So now we got to go and check our 8. Make sure we did it correctly. So we got to do 8 to the 2/3 plus 1. See if that gives us a 5. So how do we rewrite 8 to the 2/3? What's our root? Not square root. Cubed root of 8 squared plus 1. So what is our cubed root of 8? 2. 2 squared gives us 4. Then 4 plus 1 gives us 5. So that does work out. Now, on number 3, a lot of people make a mistake because they think it is isolated since it's 3x to the 5/2, but only the x is to the 5/2, not the 3. So you have to divide by that 3 first. So that gives us x to the 5/2 equals 32. Now, if it were in parentheses, like our example number 5, here we're just going to raise that one to the reciprocal power because everything's in the parentheses, everything's to that 3/2. This was not the case, only the x was. So what's our power we're going to raise it to? 2/5. So we get x equals, this is our 5th root of 32 squared. So what is our 5th root of 32? Remember how to do that in your calculator? Push the 5 since we want the 5th root. And then it's math choice 5. And then your 32. I heard somebody say it. 5th root of 32 is 2, and then 2 squared would give us a 4. So let's do our check. Check. 3 times 4 to the 5/2. We're going to see if that gives us 96. So the 5/2, that means it's the square root of 4 to the 5th power. So what is the square root of 4? 2, and then 2 to the 5th. 32. And then 3 times 32, that gives us our 96. So we did it right. So now example number 4, it gives us a negative exponent. The same rules still apply. You want to first get your x on its own, which in this case it is. And then we're going to raise both sides to the reciprocal. But since this one's negative, your reciprocal is also going to be negative. So I would raise this to the negative 1/4. Because it was 4 over 1. We don't always write the over 1, but it is there. So I had to flip it. So this gives me x equals, since it's a negative, what does it make my answer? Not negative, fraction. So this is 1 over the 4th root of 81 to the 1st power. So what is the 4th root of 81? 3. So we get x equals 1/3. So we just have to do our check. So 1/3 to the negative 4th. We're going to see if that gives me an 81. Bless you. So because it's a negative exponent, that makes my fraction flip. So now I have 3 to the positive 4. And when it flips, it becomes positive exponent. So is 3 to the 4th 81? Yes. So check that. We get 81 equals 81. So in our last one on here, again, Everything's in the parentheses, so it's already isolated. I'm going to raise it to the 2/3 power. So we're left with just the x plus 1 on the left side. Everything that was in the parentheses still there. On the right side, we got to find the 3rd root of 64 and square it. So what is the 3rd root of 64? 4. And then 4 squared is 16. So what does x equal? 15. So we just got to do our check. So 15 plus 1 to the 3/2. We're going to see if that equals a 64. So order of operations tells me to add first, so I get 16 to the 3/2. Which means I'm taking the square root of 16 and then raising it to the 3rd power, which is 64. 64 equals 64. So how do we feel about those ones so far? Not too bad? So the other one we're going to talk about today is when we have to use the same base. So your exponent now is your variable. So you got your x or whatever letter they're deciding to use, A, B, C. That's up in your exponent spot, and you need to have the same base. Remember, your base is the number that your exponent is attached to. So like in my first example down here, I have a base of 2. So there's this theorem we have that states if you have the same base, your exponents are equal. So some mathematician many, many years ago figured this out, that when the bases are the same, your exponents are equal. No matter what the exponents are, they're going to be equal to each other. So when you're solving these, you want to first check to see, do you have the same base? If you do, awesome. Makes it a little easier. If not, you're going to have to change it, and then you can set your exponents equal to each other and solve. So let's take a look at our first example. We have the same base here. We have a base of 2 on both sides of the equal sign. So that means our exponents are equal to each other. So we set them equal to each other. 2x plus 1 equals your x minus 3. And now we just solve. So I would subtract my x. So I get x plus 1 equals negative 3. And then subtract our 1. So we get x equals negative 4. Now you should kind of always do a check in your head. This one didn't say specifically to check. But when you check, again, you're just going to plug your negative 4 in for your x's. So 2 times negative 4 gives me negative 8, plus 7 gives me negative 7. On the other side, negative 4 minus 3 gives me negative 7. If you were to put your in your calculator, you get the same exact answer. 2 to the negative 7 equals 2 to the negative 7. It's the same thing. So if we take a look at example 2, though, do we have the same bases? No. I have a 9 and I have a 27. So what we need to do is we are going to come up with an equivalent way to write my 9 and my 27. But it's going to have the same base. So you kind of have to know your numbers pretty well. 9, I know we can rewrite it as 3 squared. So instead of 9, I have 3 squared, and it's still got that exponent of x plus 1 out there. Can I rewrite 27 as 3 to a power? Yeah, 3 to what power? 3 to the third is our 27, and that's still got that x on the outside there. So now we have a power to a power, so I need to multiply those. So I get 3 to the 2x plus 2 equals 3 to the 3x. Now we have the same base, so now our exponents are equal to each other. So 2x plus 2 equals 3x. You can set those equal now. So subtract my 2x, and we get 2 equals our x. Again, if you wanted to check it, you just put those back up in your exponent spots and check your answers. So for our third one there, we have 16 to the x squared minus 4x, and then 4 to the negative 8. So we got to fix those. They're not the same bases right now. Can I use 4 to a power for my 16? Yeah. I went with 4 because I saw it over here, so I'm like, yeah, let's give it a shot. What can we write 16 as? 4 squared. So we're going to have 4 squared. The other one wouldn't change. You would just leave it as 4 to the negative 8 because it already has the base that you want. So on the left side, we have to multiply our exponents. So I get 4 to the 2x squared minus 8x equals 4 to the negative 8. So now we can write our exponents as equal to each other. We're going to have to factor because I have an x squared there. So what should we do? Maybe add the 8 over so it's a 0 over there. So we have 2x squared minus 8x plus 8 equals 0. Do we have a GCF? Yes, 2. So let's divide everything by 2. I'm going to write it over here because I'm running out of space. So I have x squared minus 4x plus 4 equals 0. Now this is going to be a much easier factoring. What will this factor into? What will our signs be, same or different? Both going to be negatives. What multiplies to give us 4, but then adds to 4? 2 and 2. So we get x equals 2 and x equals 2. So that's our answer. Sometimes if they turn out to be a quadratic, you'll get 2 different answers, and when you check them, they both work. So it's okay if you get 2 different answers on those ones. I do want to do one more thing quickly. I don't even know if this is going to work. I'm going to make one up in my head. All right. I know. That's why I thought we should put it in here. All right, so we need to get these to be the same base, which they currently are not. 8's a little easier. What can we rewrite 8 as? Maybe not. 8's not a little easier. Thought 8 was a little easier. 2 cubed. So this would be 2 cubed to the x minus 5. If I were looking at just the 4, ignore for the fact that it's a fraction. If I was looking at just the 4, how could I write that as a base of 2? 2 squared. But because it is a fraction, you just have to remember that needs to be a negative 2. If it's a fraction, your exponent is going to be negative. So now we do all the same things. Multiply our exponents. So I have 2 to the negative 2x equals 2 to the 3x minus 15. Now our exponents are equal to each other. So subtract our 3x over, I get negative 5x equals negative 15. So what does x equal? We divide by our negative 5. 3. So that's the main thing there. Fraction means when you put it into your base mode, you got to make sure that exponent is negative.